Okay, this is Master Carpenter Lewis Thomas. Now, what we're going to do here is I'm going to show you some techniques that I have on figuring out mixed pitch or bastard hip roofs. Okay, and I'm going to show you how I do this on paper first. Now, I could do it. It's like many ways you can do this, but I want to show you all the theory of the math that's behind all of the things that you're going to cut on a job site. Now, this video is going to take a little longer for me to do because I'm going to be trying to explain every little detail so everything is understood as succinctly and clearly as possible. So without further ado, and by the way, this is a technique that, I borrowed some and I innovated myself, and over the years, I've been building homes for about probably 26 years, something like that. And roof cutting seems to be the hardest thing it's the hardest thing on the job site. I would even say in a residential setting, even more so than just straight stairs going from the basement or from the first floor to the second floor. So without further ado, we're going to get right into this. And the reason why I'm doing this is because I want to help somebody. If you have a job and you need some help on the job and you would like to secure our services, you just contact me by way of this channel and we can see what we can do. But first of all, let's look. And by the way, these things that I'm about to show you, you're going to be able to do without fancy calculators, a construction master, or you're going to be able to do this with just a calculator on your smartphone. You can do it with a $5, $6, $7 calculator. Now, I'm going to show you what type of calculator that I'm going to use. And this is for the convenience of those that are watching, so you can find this calculator anywhere. This is the calculator that I'm going to be using, okay? Let me do this where you can see without the glare, all right? It is the TI 30XA. Okay, it appears backwards here, but that's what it is. And it's a Texas Instrument. So let me start it off like this, okay? Let me start it off like this. Melchizedek, give me a carpenter's pencil out of my pouch in that speed square. So what I'm going to do, normally I do it with a carpentry pencil, but because I want the visibility of this to show good up on the video, what I'm going to do is use a permanent marker that I bought at the dollar store, okay? Because I want you to be able to see exactly what I'm doing. When I was learning roof cutting and carpentry, it's a lot of stuff that people don't want to show you on the job site. Maybe they have a position field, maybe they have a favorite person, maybe it's a family company, and blah, yada, 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 whatever the reason is. So I had to take the initiative to learn some things for myself. One of the things that helped me is this book right here. I'll show you this book. This book is called Roof Framing. It's by a guy named Marshall Gross. Now, this is a very high level technical book. It's one of the most technical books I've seen on the subject. And it's one in there somewhere. But without further ado, and this is a pretty thick book. This is the back of it, the author of the book in the back of it. I guess it's upside down. And this is Marshall Gross. Now, this book is poorly constructed. It's a poorly constructed book, but it has some really good information in it. And it really helped me to double and triple the income that I was making in this trade. So if you can get this book and order it and start learning it and studying it, you are going to be okay. Now, let's get right into it. Now, I want to show you something here. Who is that in there? Okay. Now, the first thing we're going to do is, first thing that we're going to do in this exercise, I'm going to show you, we're going to draw a triangle, okay? Now, I'm drawing this extra big for illustration purposes and for this video, okay? So, you draw a triangle is what we're going to do first, all right? We're going to draw a triangle first, okay? Right angle triangle, all right? What happened? So we got a right angle triangle here. All right. Now, what we're going to do is label. Well, I'm going to draw out everything first, the whole model. Okay. So and I'm showing you how I do this. So and I'm being very methodical about the way I'm doing it, so you can get the gist of what's going on here. With this technique, you're going to be able to figure out any roof, no matter what the overhang is, no matter what the pitch is. If it's an odd pitch, like 12 3/8 pitch, it won't matter. Metric, whatever. You know, you just convert everything over to metric. So this is a very, very, very powerful technique. Very powerful technique. Okay. Now you have to watch everything that I'm doing here and how I'm doing it. You see, I have the same parallel from this to the edge of the sheet, and I just put a dot at the end. Now what I'm going to do with that dot, I'm going to draw it up to that corner there. You see that? See how I did that? Now I want, at that same dot, I want to draw it over to this corner here, this intersection here. You see that? Then what you do, and that's showing up pretty good. We got a little bit of glare on the paper, but that's pretty good. You're able to see what's going on here. And we're going to connect these two. And we're going to connect these two. Now I'm going to explain to you what exactly you're looking at, so you can have some perspective. All right. And I'm going to finish drawing the whole thing on out, and then I'm going to explain everything. So now this line here is actually a buildup for the difference in plate height. Okay. That's what this other line represents. It's a buildup for the plate height between the two different pitches. Okay. So all of the section where you see a triangle at, that represents the steepest side of the pitch. You see this triangle up in here, and it looks like it's higher. Well, that's the plate height. Okay. Now watch this. What we're going to do, I want to do something else here. Let me do something else here. Okay. Now what we're going to do, this side right here, that triangle right there, okay? This triangle right here that I'm tracing, that side represents the steepest side of the pitch. And in this case, it's going to be a 12-12 pitch, okay? So we're going to do this, 12-12 pitch, All right. You know what? I want to do 1312. Let's do 1312. I'm going to make it even steeper. 1312. 1312. Okay. That represents this side. This side right here on the other side of the hip, that's going to represent 812. All right. 812. That's your pitch, 812. Now I already know right off the top of my head what the hypotenuse is. It's 14.42. Okay. I'm going to show you how to do that on a calculator. Okay. To do this on a calculator, what you have to do is this. I'm trying to get it where the glare is off. Okay. What you do is you 14, and then what you do is press squared. You square it. Okay. You press the squared button, which is the X and that little 2. Okay. You square plus 12 squared equals, and then you press the square root button. Okay. And it's 1843. Well, it's supposed to be, oh, so something is wrong. I must have put in the wrong number. 8 squared plus 12 squared equals, and now you press the square root. You got 1442. So I'm right here. So we're going to do the same thing for the 1312. Okay. The 1312. Okay. So what we're going to do is 13 squared plus 12 squared equals, and then you want the square root of whatever that number is. And it's 1769. So we're going to write 1769. Okay. 17.69. And we want to put the inch mark there too. Let's just get in the habit of doing that. Okay. So now what we want to do for this side, I always figure out the lowest pitch first. Always figure out the side of the lowest pitch. The side for the lowest pitch is this pitch here. And this is the run and the rise, total rise for the 812 side. Now we're going to plug in a number here, which is we're going to make the run 7 feet. Okay. Which is equals 84 inches. All right. Now, what we need to do here is figure out what is the rise. Now, we already know that the pitch of this is going to be 812. So what we want to do is 7 times 8. Okay, is 56. So we're going to plug in 56 here. 56 inches. Now, 56 inches is from here, from this line, this horizontal line here, all the way up to the peak of the roof. Okay. Now, the way that we're figuring these things out, these rafters out, is by the actual length of the rafter. Okay. The actual and apparent length of the rafter. All right. So it's going to be 86 inches. Now what we can do is 7 times 1442 is going to give us how long this hypotenuse is. Okay. So we're going to say 7 feet times 1442, which is the hypotenuse. That means that you're going to have 1442 inches of hypotenuse for every foot of run. Down here we have 7 feet. So 7 times 1442 is what? 194 inches. So we got 194 inches. Now we want to turn that into feet, which comes out to 8.411 feet. Now, I'm going to show you how I come up with those answers. So 7 times 1442. Look at this. 7 times 14.42 equals 100. Hope you can see that. Equals 194. Okay. Now that you have the whole side for the 8 figured out, you actually can start cutting the commons for this. Now we haven't figured out the overhang. Okay. So our measurements right now, as it stands right now, go from the final tip of the 812 common all the way to the building line. That's without an overhang. Okay. So we're going to proceed. Since we have a 1312 pitch, okay, since we have a 1312 pitch on this side, okay, this is going to be the king common for the 1312 side. So what we have here, what we have to do is subtract 8 from 13, and that is 5 inches. So 5 inches minus 56 inches is going to give you 51 inches. Why 51 inches? Because you're going to build the plate up 4 inches. Okay? I mean 5 inches. You're going to build the plate up 5 inches or allow for it in your seat cut, which I won't go into right now. That's a little more complicated and advanced. So now we have the exact rise from the buildup on the 1312 side to the top of the common rafter. Okay. And that rise is 51 inches. Now, what you do here now to figure out the run, you take 51 and you divide it by 13. And you get 3.923. All right. That's feet. Okay. So 3.923 feet. All right. Now we want to change that feet also into inches. To do that is very easy. You just multiply whatever the number is already in there times 12 equals 47.076 inches. 47.076 inches. Okay. So that's the run from the building line all the way to the common cut, the ridge cut of the common. Okay. Now what we need to figure out, we got the rise, we got the run. Now we got to figure out the hypotenuse, which would be the total length of the rafter from the ridge cut of the rafter or the plumb cut of the rafter all the way down to the building line, or the HAP, H-A-P, which means height above plate. Okay. So your HAP line or your building line, some people call, or your stance, people call it different things. So there are several ways that I could do this, but what I'm going to do is I'm going to do it this way. We're going to do this one the same way we did the 812 side. We're going to take 3 point, let me see. I want to make sure you can see some of these numbers. Okay. 3.923 times the hypotenuse of the 1312, which is 1769, times 17.69 equals 6939. Okay. So we're gonna punch that in. 69. We're just gonna round it off to 69. I like to do it exact, but so let's just do it exact since I like doing it that way. 39.7. Okay. And that's inches. Now you want to turn this into feet. You divide by 12. And it comes out to 5 foot, 5.783 feet. Okay. So now we have our commons figured out. We have our king common for our 812 figured out. We have our king common for our 1312 side figured out. Now we got to go to the next step. Now this house is going to have an overhang, okay? I'm going to do a simple overhang here for illustration purposes. Okay, let's say that it has a 1 foot overhang. That's from the building line all the way to the outside of the finished fascia, which is, let's just say 12 inches. All right. So you see that I have 3.923. That's the run of the actual. But now we're going to add so we can have something for overhang. So what we're going to do is 4. We're just going to add a foot to this. So it's just going to be 4.923. Because you can see it's already 3.923. Adding a foot, just adding another 1 to the 3, which we're going to make it 4. So we got 4.923. And on this side, the overhang for this side is going to be a foot too. And I want to tell you, it really don't, when you're doing it this way, you could, the overhang could be 4 feet, 5 feet, 8 inches, 4 inches, and you're going to come up with the exact measurement every time. So we have a 7 foot run here. So all we have to do to add 1 more foot is 8 feet, 8 foot. Now what you're going to do is you're going to take 8, okay, and divide 8 by this 4.923. That's what you're going to do. So we're going to do the 8. I want to make sure you can see it without glare. 8.9. Uh-oh, that's wrong. Okay, 8 divided by 4.923 equals. So this is going to be 1.625. I think this is called the secant, okay? When you have the rise divided by the run, it's called the secant. Now that 1.625 that's already in the calculator, you want to take that and multiply it by the run. So it's going to be 1 foot shorter than this. You want to take this number and divide it by, multiply it by this number, times 3.923 equals 6.74. Now, look at this. 6.3749. Now, if you don't understand some of the things that I'm saying here, please, in the comment section, let me know what you need clarity on, and I will do another video where I will give more elucidation to some of the things that I'm explaining here. So let me show you what just happened here. When you divide this 8 feet with the overhang and the run by this overhang and run, which is 4.923, it gives you like a secant measurement, which would be 1.625. Now, the 1.625 is this right here broken down into inches, okay? Each inch is divided up into 1.625, okay? You take that number and multiply it by this, and that's going to give you the exact length from the king common all the way to the hip. So this lets you know where you need to put your hip if you're measuring from the king common. Okay, so watch this. So now this is the run here for the buildup of the plate height on the 1312 side. Okay, you take this measurement, 6.3749, and what you do is you take this 7 feet and you subtract 6.37 from 7 feet. So let's do that. Okay, so what I'm going to do is that. So 7, I'm punching in. I want you to see this without a glare. I'm punching in 7 feet minus, now I stored it in the calculator, so I'm just going to put recall 1 equals 6.25. So the remainder is 6.25. 6.25 is significant because another way you can figure out where this hip goes, the center of this hip goes. Now, the measurements that I'm giving you are for finding the center of the hip, okay? Now, this line right here represents the inside. Let's say, this is just for illustration purpose. Let's say you got a 2x12 here, okay? And this is the top of it. This line right here, it represents the inside, the side that's closest to the hip. It's not the center line of the hip. It's the inside of the king common, okay? So yeah, that's something that's important to know. And it's the same thing with this one. If you take it and put some width to this line, you would see that this is the inside of the king common for the 812 side, okay? Now, this is all I'm going to do for today, right now. And so I'm going to stop here and I'm going to pick up part 2 later on because I want this to upload very quickly. But anyway, this is Lewis Thomas, Master Carpenter. And what we're doing here is we are studying easy ways to graft out, mathematical ways to graft out, figure out any type of hip pitch roof in the world. Any type of hip pitch roof in the world. It don't matter. If you got this technique, you can figure out any hip. You don't need a whole bunch of scales, tables, calculators, and all this. All you need is a simple little $6 calculator, and you can figure out any roof out there. And you can make a good wage. But anyway, that's enough for today.